All right, guys, welcome back. I just wasted 10 minutes of my life because I've been here way too long and my brain is malfunctioning. Hopefully, you guys enjoyed yesterday's lesson. I think it's pretty fun. Today, not as fun, but still fun. Water current problems. That's right, props. They ran out of space. So basically, this is like if you're swimming with the current. So if you're going like swimming and the water's going with you, it's like, ooh, I'm going faster. Or if you're trying to swim back into shore and the water's going out the shore, you're like, ugh, I'm dying out here, guys. So if it goes with you, you're going faster. If it's going against you, you're going slower. The formula you want to remember is rate times time equals distance. We've used this before. Ugh, my eyes, I'm so tired. Okay. So the thing that you'll want to remember with rates is, you'll see in a second, if the rate is, if the, current is with you, okay, with you, your rate will be faster. W being the rate of current or of wind, they're treated the same way. And if the current or the wind is against you, you're going to write R minus W or whatever variables you want for the current, where that R is your normal rate if there is no wind or no current. So obviously, like if you're running and someone helps push you, your total rate will be a little bit faster. If your rate is you're running and then someone's like pulling your shirt back, you're gonna go a little bit slower for your entire rate. So we're gonna do an example, and I'm gonna be smart because it's my second time and I know I need more space. So I'm gonna try and simplify this. A jet goes 6,800 kilometers. The book says it's going from New York to Paris, but that doesn't matter. In 6 hours, 48 minutes with the wind. The wind is helping push it, so it's going to go faster. The return trip takes 8 hours. So obviously that's against the wind. It's going to go a little bit slower because the wind is being like, you shall not pass. Lower the ring there. So the question, find rate of jet in still air with no current, and then find rate of the wind. So we already said that rate times time equals distance is your friend. Rate times time equals distance is our best friend ever. So with the wind, we said our rate is R plus W. How long does it take us? 6 hours, 48 minutes. However, you either want everything in minutes or everything in hours. You want the same units. We want hours though. So 48 minutes, to convert to hours, you have to divide by 60. I already did this. It is 0.8 hours. That total trip was 6.8 hours. Your distance was 6,800 kilometers. Your return trip you still have to go 6,800 kilometers. However, it takes you 8 hours and you're against the wind. So your rate is R minus W, slowing you down. Get off my back, yo. So I'm gonna have R plus W times 6.8 equals 6,800. And I'm gonna show you this the smart way, but then explain how most problems you'll do it. I totally butchered this one. I was gonna take forever to solve it. It's like, no thank you. All right, normally you would distribute these to the R's and W. However, then we get decimals. Then you wanna get rid of the decimal and you'd have to multiply things to cancel them. So if you see, we already have a plus W and minus W. That's on the right track. Sorry, desk. So if I, instead of distributing, just divided, I would have R plus W equals 6,800 divided by 6.8 is 1,000. And then if I divided this one by 8 instead of distributing, 6,800 divided by 8, I get 850. If you add those together, because I can add them right away to get things to cancel. This is going back a couple sections ago. Don't even have to multiply them. I get 2R equals 1,850 divided by 2. You get 925. So the rate of the jet is 925 kilometers per hour. Shazam. And then for wind, well, our equation here says R plus W equals 1,000. So if the jet's going 925 kilometers an hour, the wind's got to make up that difference. So if I subtract, that means the wind is going 75 kilometers an hour. That sounds pretty dang fast to me. And that's how you do it. So rate times time equals distance. If you notice that it's going to give you something ugly if you distribute, just divide right away. And it's like your normal system of equations. I did want to do one more for you guys, even though the book stops there. Let's do 18. Lost my good back over there. Stop it. 18 says a motorboat has 4 hours of gas. How far from the marina can it travel? If the rate going against current is 20 miles an hour, miles per hour, and rate coming back is 30 miles an hour, and that is with the wind, or with the current wind current. All right, so what did we say our favorite formula is? Rate times time equals distance. So basically you have a boat from the starting point in the docks in the marina. It leaves, it's going against the current, so it's going slower, and it's like, I gotta get back because I only have 4 hours of gas. It's been a while. And I'm trying to go back, but I'm able to go a little bit faster on my way back because the current is with me, so it's helping me go faster. How far can I go? So we have against, and we have with the current. It says the rate going against the current is 20. The rate going with the current is 30. We have 4 total hours. So we don't know how far we can go against, how much time we can spend, but whatever's left over, 4 minus x. If I took 1, I'd have 3 hours here. If I could go 2 hours, I'd have 2 hours there. If I could only go 1 hour, I could have 3 hours here. So a total of 4 hours. Distance, yo no sé nada. We don't know. So that's 20x. And this is 34 minus x. However, if I go out, that's the same distance as me going back, right? Same thing. When I flew to Paris, I have to go the same distance to get back home. Assuming I lived in New York, but I don't. All right, so note to self, don't do math when you're super tired. Take a break, because I just butchered that. So the distance going out there should equal the distance of me going back. When I wrote this one, I forgot there's an x there, so I failed miserably. 20x equals 120 minus 30x. So I'm going to add 30. So I'm going to have 50x equals 120. 120 divided by 50 is 2.4, right? That's the time. 2.4 hours, just under 2.5 hours. But my distance, right, is 20 times 2.4. 20 times 2.4 is 48, and our units is miles. So keep in mind, we didn't do a system of equations problem here, but we did use the rates and the time. So keep that in mind. You may not always get a system of equations. Set up your table and be confident in your abilities. And that is it. I'm going to get some sleep. Probably not, I still got to. But I'll see you guys some other time. I don't know when.